Good morning friends, I am back again with one more video lecture on the topic complex number. In this video lecture, we will solve one interesting problem based on the complex number, and problem is find all the values of 1 plus I to the power 1 by 3 and show that their continued product is 1 plus I. Now first we express this 1 plus I in terms of polar form. So let this 1 plus I is the x plus I times y is equal to r times cos theta plus I sin theta. Now here x be the real part of the complex number and y is the imaginary part of the complex number. So here x is equal to 1 and y is equal to I times 1. So here 1 is the imaginary part of this complex number and r is the modulus of the complex number or absolute value of the complex number, where r is equal to root x square plus y square. So here x is 1 and y is 1, the 1 square plus 1 square. So this answer is root 2. And theta is the amplitude of the complex number or argument of the complex number. So here theta is equal to tan inverse y over x. Y is 1, x is 1, the 1 over 1 answer is 1. So here answer is tan inverse 1 and tan inverse 1 is pi by 4. So here amplitude is equal to pi by 4. So therefore this 1 plus r is equal to r means root 2 cos theta. So here theta is pi by 4 plus I sin pi by 4. Now denote z is equal to this 1 plus I to the power 1 by 3. Now 1 plus I is root 2 cos pi by 4 plus I sin pi by 4 and this is to the power 1 by 3. Now root 2 to the power 1 by 3 answer is 2 to the power 1 by 6 because root 2 means 2 to the power 1 by 2 and 2 to the power 1 by 3. So according to laws of indices, 2 to the power 1 by 2 times 1 by 3, the answer is 2 to the power 1 by 6. Now this cos pi by 4 plus I sin pi by 4 to the power 1 by 3. Now we recall trigonometric formula cos theta plus 2k pi, answer is cos theta. Similarly sin theta plus 2k pi, answer is sin theta, where k is positive integer. In general form, the z is equal to 2 to the power 1 by 6 cos theta plus 2k pi. So here theta is pi by 4 plus I sin theta plus 2k pi. So here theta is pi by 4. So pi by 4 plus 2k pi and to the power 1 by 3. This is equal to 2 to the power 1 by 6 cos. Now here pi is common and cross multiplication. So 1 plus 8 times k divided by 4 times pi plus I sin 1 plus 8k times pi divided by 4 to the power 1 by 3. Now according to De-Moivre's theorem, cos theta plus I sin theta to the power n, answer is cos n theta plus I sin n theta. So therefore by De-Moivre's theorem, 2 to the power 1 by 6 and cos theta plus I sin theta to the power 1 by 3. The here n is 1 by 3. Answer is cos n theta plus I sin n theta. So cos 1 plus 8k times pi upon 3 times 4 means 12 plus I sin 1 plus 8 times k times pi upon 12. Now 1 plus I to the power 1 by 3 have 3 values. Therefore substituting k is equal to 0, 1, 2. Now substituting k equal to 0, we get the first value and it is denoted by z1 is equal to 2 to the power 1 by 6 cos k is 0, so 1 times pi, pi by 12 plus I sin pi by 12. Now cos theta plus I sin theta, we write it as e to the power I theta, therefore 2 to the power 1 by 6 and this cos pi by 12 plus I sin pi by 12 e to the power I times pi by 12. Now substituting k equal to 1, we get the second value of z, it is denoted by z2, this is equal to 2 to the power 1 by 6. Now 1 plus 8 times k is 1, the 1 plus 8 answer is 9, 9 pi by 12, the cos 9 pi by 12. Now here 3 get cancelled, but for our convenience we write it as 9 pi by 12 plus I sin, again 1 plus 8 times 1, 9 pi by 12. Now this is equal to 2 to the power 1 by 6. Now cos theta plus I sin theta, answer is e to the power I theta, here I times, here e to the power I times theta, theta is 9 pi by 12, 9 pi by 12. Now substituting k equal to 2, we get the third value of z, it is denoted by z3, this is equal to 2 to the power 1 by 6 cos 1 plus 8 times 2, 8 times 2 16, 16 plus 1 17, 17 pi by 12 plus I sin 17 pi by 12 and this is equal to 2 to the power 1 by 6, e to the power I theta, here theta is 17 pi by 12 and therefore all the values of 1 plus I to the power 1 by 3 are z1, z2 and z3. Now continue product of z1, z2 and z3, answer is z1 times z2 times z3. This is equal to, now z1 is 2 to the power 1 by 6 times e to the power I pi by 12 times z2 is 2 to the power 1 by 6 times e to the power I times 9 pi by 12 times z3 and z3 is 2 to the power 1 by 6 times e to the power I times 17 pi by 12. Now according to laws of indices, 2 to the power 1 by 6, 2 to the power 1 by 6, 2 to the power 1 by 6, 2 to the power 3 by 6. Now according to laws of indices, e to the power I pi by 12 times e to the power I 9 pi by 12 times e to the power I 17 pi by 12, answer is e to the power I pi by 12 times 1 plus 9 plus 17 and this is equal to 2 to the power 3 by 6 means 2 to the power 1 by 2 e to the power I pi by 12. Now 1 plus 9 is 10, 10 plus 17, answer is 27. Now 2 to the power 1 by 2, e to the power, now 27 by 12, the answer is 9 by 4. So we write e to the power I pi 9 by 4. Now this is equal to 2 to the power 1 by 2. And e to the power I theta, again cos theta plus I sin theta, so cos 9 pi by 4, here theta is 9 pi by 4 plus I sin 9 pi by 4. Now this is equal to 2 to the power 1 by 2. Now 9 pi by 4 we write it as pi by 4 plus 2 pi plus I sin, again 9 pi by 4 means 2 pi plus pi by 4 Now again we recall the formula cos theta plus 2k pi, answer is cos theta where k is positive integer. Similarly sin theta plus 2k pi, again answer is sin theta if k is positive integer. So this is equal to this 2 to the power 1 by 2 as it is. Cos theta plus 2 pi, answer is cos theta means cos pi by 4 plus I sin, again sin theta plus 2k pi, answer is sin theta if k is positive integer. So here answer is sin pi by 4. Now cos pi by 4, answer is 1 upon root 2 plus I sin pi by 4, again answer is 1. Now 2 to the power 1 by 2 means root 2. So 1 over root 2 plus I times 1 over root 2. Now root 2 times bracket, this root 2 get cancelled, the answer is 1 plus I. Now therefore continued product is 1 plus I. Hope all of you have understood this problem. In the upcoming lecture, we will solve some more problems based on the complex number. Please subscribe the channel and let me know your comments and feedback. Thank you.